Hello and welcome to Small Cells and Smaller Devices using 5G to solve IoT device security. If you are joining us live, our speaker is in Slido right now answering your questions. For audio or video issues, click the technical support button below. I'd now like to turn it over to Senthil Ramakrishnan for the presentation.
Thank you, Britta. And thank you everyone for joining this session. My name is Senthil Ramakrishnan, and I am part of the AT&T business organization, specifically the IoT organization. Thanks again for joining, and as Britta mentioned, if you have any questions or any other discussions you'd like to have, please reach out to me via Slido. Over the next 30 minutes, we are going to be talking about IoT, some of the security challenges that IoT deployments face today, specifically on the device side. And then we will focus on how 5G and some of the 5G network capabilities will help solve some of these IoT challenges. And again, we are going to be focusing specifically on devices and the challenges that they face. So we'll start off by talking about what is IoT, right? This is a term, this is another industry buzzword that probably everybody on the presentation has, or the session has heard. IoT, or the Internet of Things, really is just a network of connected devices that are deployed out in the field, that are collecting information, any type of information, and sending it back for post-processing or by applications. These applications might then take some decision and then force some action through some command and control using these same devices themselves, right? So there's been an explosion of IoT in the last few years. Today, I think the estimate is around 2.5 billion devices, IoT devices, deployed globally on various types of connectivity. The growth is expected to be much larger. Numbers anywhere between 20 to 50 billion IoT devices over the next 5 to 7 years are expected. That's a huge growth, right? But the thing we have to realize is not all IoT devices are the same. And we'll start off with something as simple as the connectivity piece. When IoT was starting to grow a few years ago, about 70 to 75% of these IoT devices were expected to be on Wi-Fi. But as these devices started getting deployed, mainly because Wi-Fi is cheap, is easily available, easy to deploy, right? But what was happening was there is no inherent security built into Wi-Fi. And enterprises were starting to see that their IoT deployments were very vulnerable when they were using Wi-Fi. And so cellular IoT started gaining traction, and it's going to continue to gain traction as well. So today, it's around 10 to 15%, and that's expected to grow up to 25%, right? And with the advent of or the introduction of technologies like LTE-M, narrowband IoT, and 5G, that traction for cellular IoT is going to continue. Now, before we jump into the challenges that IoT brings, let's talk about the IoT architecture. Very simply, you can break it down into 3 layers. One is the device layer, the connectivity layer, and then the data and application layer. Now, the device layer is any IoT device. It could be something as complex as a smart building or a connected car, or it could be something as simple as a temperature sensor or a flow sensor out in an oil field, right? So all of these different types of IoTs comprise this layer. Now, a lot of these devices have connectivity directly built into them, but some of them also have a gateway in between that these devices are talking through, right? The next layer is the connectivity layer. Now, the connectivity layer is essentially the transport layer that is going to carry the data from your device to your backend application. This could be cellular. We talked about Wi-Fi. It could be wireline, satellite, all types of connectivity. It could be private, public. It's a wide range there. Now, these networks are carrying this data back to a set of platforms or applications that are sitting in the back end. And these platforms and applications are broken down into 3. Right? There's an application enablement platform, which is essentially the Azures, the AWSs, any of the Googles, any of these cloud providers where you can run your application. The second is your connectivity management platform, which is what you use to manage how your devices connect. And the last one is the device management platform, which is what you use to manage your devices itself. Now you put all of these together and you get the IoT ecosystem. Now, IoT in the real world, right? The IoT is essentially everywhere you look. Any industry, whether it's some of the older industries like manufacturing, industrial, to newer industries like drones, agri-tech, wearables, healthcare, any essential industry today has some type of IoT deployment available, right? And the rate of deployment is continuing to grow because at the end of the day, the more data you have, the more educated decisions and actions you can take, and IoT is going to enable that. So really, the application of IoT is very widespread, and new applications are coming out even as we speak. Now let's get to the interesting part, right? Now we have a good, at least an introduction to IoT. Let's try to understand what the security challenges are. Now, the first thing to really understand is IoT is very different from IT. And we're going to spend some time really understanding what those differences are, because those are what are going to define what the threat vectors and the security challenges really are going to be. Now, if we look at the same model where we have the three layers, the device, the network, and the application, you'll see that there's a wide set of vulnerabilities and compromises that can happen. Right? But the challenge with IoT is that, although you can secure your backend application because it's really running in one of the cloud providers and they have a lot of solutions out there, and it's connecting, and you could connect using one of the more secure connectivity options like cellular, when you come down to the device, that is where the challenge rises. Because most IoT devices are going to be really low-powered devices that don't have a lot of processing or memory capability on them. So the ability to add security capabilities to these low-powered devices is a big challenge. And the second is that these devices are very cheap, so you're not going to be able to add cost to it by increasing security capabilities on that. So that's probably the number one challenge or security gap for IoT, is that device and its ability to be secure by itself. So let's talk how that impacts IoT security, right? So let's talk about volume. Let's take the example of a car manufacturer as our example enterprise for this slide. Right. So a car manufacturer will have multiple IoT applications. It could be something to monitor their industrial manufacturing plants, asset tracking, worker tracking. It could be the connected cars themselves that they're offering as a service to their end customers. So there's going to be a large volume of IoT devices that are going to be deployed out in the field. And all of these devices are going to be different, right? They're going to be deployed in various environments, in various geolocations. And each of these devices are going to be different. The sensor that is sitting and measuring, the temperature inside your factory, or a critical component in the factory, is going to be very different from the sensor or device that is inside your connected car. So there's going to be a wide variety of custom devices, really, that are deployed out into the field. Now, the challenge this raises is that you cannot have a singular or common security solution that can be used to secure all of these devices. Now, we talked about these custom devices, right? And that extends really both into the hardware and software world, because you're going to have custom hardware built either by a tier one, or you're buying it off of the shelf and putting it together, right? Like a system integrated type model. And the software for IoT is completely different. Right? There's real-time operating systems. There's not a lot of use of standard operating systems like Windows or Mac OS, even Android. Right? These are very, real-time operating systems for smaller devices, and then Unix and Linux variants across the rest of the ecosystem. There's a lot of effort to try to unify that, but even today, it's very split, very fragmented. So again, the challenge that this brings forth is how do I manage these devices? How do I maintain the security lifecycle for all of these devices? That's very difficult. You can't use your standard, device management solutions that you use for your IT devices, your laptops, your phones. None of those are going to work in this case, right? And then device access is another challenge. IoT devices are going to be almost like a deploy and forget type model where the device is out in the field. And in a lot of cases, in a lot of verticals like smart cities, these devices are available in public spaces. It can be a smart lighting system, et cetera, that has connectivity back into the city's IT systems. And now these devices could then be easily accessible, and if not secured properly, easily compromised, which would then allow access back into the enterprise's IT systems and backends. So, in a traditional IT system, the risks are really data loss and compromise of data and leading to some lost revenue and resources. But with IoT, those risks are amplified because there's, depending on the vertical, that is also impact to life, right? You could take connected car or autonomous driving as an example. Even something as simple as industrial systems could be compromised and made to malfunction and impact worker safety in that location as well. So IoT brings some unique challenges that are exacerbated by the inability to fully secure these devices. So how do we go about securing these devices? That's what we're going to talk about next. So what we recommend really is a multi-layer approach to security. You have these three layers, and you have to have security solutions in all of these three layers. You have to have threat management that looks at the ecosystem end to end. But the problem, as I was talking about earlier, is that these devices are not able to have a full swath of security solutions deployed on them. Today, most of these security solutions are sitting at the very end, or the opposite end of this ecosystem, meaning they're all sitting at that data application layer. So these devices are essentially, open and vulnerable, and all protections are made to the data that's coming in at the application layer. And that obviously is not a good solution because that is a weak link in the entire chain. So this is where 5G comes in, right? 5G brings about a new set of capabilities that allows the enterprise to bring security solutions closer to the device. So even though the devices continue to stay low-powered and possibly insecure, your ability to bring these security applications and security solutions at the edge of the network allows us to provide a better risk level to the enterprises. Thereby, even though there is some security issues in the end-to-end solution, your risk is now at a much more acceptable level, and so you can be more confident in deploying your IoT solution into the market. So I'm going to stop there, and feel free to send any questions regarding IoT and IoT security via Slido, and I'm going to transition over to the 5G part of this discussion as well. So let's talk about 5G and how it's going to help the issues that we talked about with IoT devices, right? So what does 5G bring? 5G again is another term that we're hearing in the market every day, and how is it going to help IoT? I wanted to point out a few capabilities that are going to be important from a security perspective later on, right? First one is ultra low latency, right? 5G is going to bring less than 20 millisecond round trip latency between your device and your backend application. Now that's important because today on 4G LTE, that latency can be anywhere between 75 to 150 milliseconds, depending on where your device is, right? And latency is important, and we'll talk about it later. The second one is reliability, right? Your ability to support mission-critical devices when they are out in the field reliably at high availability is very critical, right? It's important from a security perspective as well. Next one is we talked about the volume of IoT devices. 5G supports massive IoT where you can have a very large number of IoT devices in very dense deployments because of small cells and other capabilities that 5G brings. And then some IoT applications or verticals require ultra-high bandwidth as well, so 5G brings that to the market as well. Continuing, when you compare 4G to 5G, 5G is an edge-to-edge transformation. That means from the devices through the network all the way to the back end, everything is completely changed, right? We talked about the radio access part, which is the low latency, the ultra-high speed, the massive densification, but it also brings some other capabilities that we're going to jump into next. So two things that 5G really brings to the market when you look at the architecture, two massive changes that are brought about in 5G deployment. First one is virtualization. Moving from 4G to 5G, we're essentially moving to a software-defined network-based architecture for the entire 5G network. Now, this is groundbreaking because this SDN-based architecture allows us to do some very critical things with respect to security and resourcing. And we'll talk about that next as well. The other change that 5G also brings about is the separation of your control and user plane inside. This is called CUPS, control and user plane separation. And what this does is it really separates the network management functions from the user functions, meaning the actual data that is being carried between the device and the backend application. Now, this is important because from a security perspective, now you can have separate security policy for your control plane as well as your user plane. And that is important because these devices will be using the user plane, and having the ability to add security policy to it becomes critical because now you're adding security layers and helping protect that vulnerable device. The other changes, which are just as important, is this move from a centralized network core to a highly distributed network core, right? So that plays into the high reliability and high availability feature of 5G. The other important and very important part of the 5G network is the addition of the edge. Now, we talked about how today most of the security solutions are running at the end of the IoT ecosystem, which is really the application and the data layer. Now, the addition of this edge to the network does two things, right? One is now you're able to add network security capabilities. This is to protect the network itself. Those can be added to the edge. And you can also bring user or device security services to the edge as well. There's other improvements to the 5G technology, which includes increased over-the-air and user plane encryption of the traffic, and also some subscriber privacy and identity changes as well. So overall, the 5G evolution or the 5G advancement really brings protections to the network layer, and that fixes some of the vulnerabilities that were uncovered in 4G LTE. Now, this is separate from what we're going to talk about in the application layer, which is what is applicable really to protecting these IoT devices. We talked about the subscriber identity privacy. We talked about some additional security functions that are introduced into the network. Some verticals in IoT really have devices that are moving around, in many cases moving networks as well. An example is containers, right? We're tracking containers, refrigerated containers. So in these cases, you're moving networks, you're moving geographic locations, and so 5G brings around security when you cross network boundaries as well. Another change to the 5G security architecture was the introduction of domains. They've really created a hierarchy within the architecture where you have a network access, a security domain, which is really how your device is authorized and gets access into the network. You have a network domain security, which is some of the things we talked about, which is how the network itself is secured with the communication between the infrastructure. And then two important things is the user domain security and the application domain security. This is where the user traffic and the application traffic itself are able to be secured by additional services that can be introduced. Now let's talk about the user and the application domain, right? So two things that really stand out to me. One is network virtualization and edge-based security. Well, now network virtualization really means, most of the network components are SDN based, right? So now what you can do is allocate resources based on need for each of these network infrastructure. So essentially, you could create a slice throughout the network, end to end in that network, and dedicate that slice to specific IoT use cases. We'll talk about that. Edge-based security, we talked about it, moving the applications and services, specifically device security applications and services, as close to the device as possible is now a feature that 5G networks are going to support. So slicing, right? Now, as we talked about all the different verticals with IoT security, with IoT, you'll see that not all of these verticals are the same, right? Autonomous vehicles might require high bandwidth, low latency, and high security, whereas a industrial type deployment, which does not require high latency or high throughput, would still require security policy. And so each IoT vertical might have its own requirements. And so with virtualization, we're able to take the network and slice it into different network slices so that you can use those and base your resources on what is actually needed. And so in this example, we're talking about a transport layer where we have low latency, high bandwidth, and high security. Right? Same thing for healthcare, but you might not need high bandwidth in a healthcare scenario, so standard bandwidth could be used. So, slicing is important for devices because now you can take insecure devices and put them on a slice where they will not impact other devices that are doing mission critical capabilities, right? So, healthcare, for example, devices that are insecure can be put into a healthcare slice that does not, cross-pollinate into other mission-critical devices. So that's why slicing plays a very important role here. Next, when we get to security at the edge, this is where some pretty interesting things can happen, right? So for the past decade, really, we've been talking about the cloud. Right, move your applications to the cloud, and it was easy to do. Right, it's cheaper. It's it's standardized. You can go build your applications there and move them around to different clouds. So that move to the cloud has been very popular over the last decade, really. But now, with the introduction of the edge, that is this new decentralization of the cloud that is happening. Right, you don't have to move your applications or keep your applications in a high latency scenario when the edge allows you to perform those actions much quicker, right? So I want to introduce two terms, right? Decision latency and action latency. And it's important in the IoT security use case because when you have things like, AI or machine learning based threat detection running at the edge, and you identify a compromised device or a scenario which needs to be a security scenario that needs to be rectified immediately, you have that low latency and that low decision latency to be able to get that data, make that decision, and then take action at it. You're not sending data all the way back to the cloud before you make that decision and then take that action, right? And you have multiple edges in the 5G world as well. You have a mobile edge, which is at the front of the network, right? So that could be even deployed on-premise. And then you have a network edge, which is within the network or inside the network core as well. So depending on your application, depending on your latency requirements, you could run your services in either of these edges. So examples of IoT security services that could be run there is device identity, right? When you have things like narrowband IoT devices, which have very low bandwidth, use cases, right? And so you can't have a very heavy authentication algorithm running all the way back to the cloud before you let that device onto the network, right? I just want to wake up 5 times a day and send 2 kilobits of data, right? That's my use case. But I still need to be secure. So running some of these services, these authentication device identity services at the edge allows you to do that. So again, depending on your application and services, you have a lot of areas where you can deploy these security services. And this is just an illustration of that security at the edge, right? When you have a varied type of device deployment for your IoT ecosystem, you could use the edge to set up device adapters so that the edge application, your security application, could talk to any variety of devices without having to worry about protocols, etc. So again, we're taking away that challenge of a variety of devices, and we're taking away the challenge that all these devices cannot be managed by a single application, because now you're moving those applications more to the cloud, and you can also run these device adaptive services at the cloud as well. Now, we're all familiar with the zero trust security model, right? And because of this virtualization, the network slicing, and the ability to use the edge to limit access to the back end, you can now deploy this zero trust security model much more simpler and much more quicker with 5G, right? Now, all your devices do not have to talk back to the backend application. You don't have to open up your firewalls to 10, 20 million devices that are out in the field. You can now limit that to a small set of edge-based devices or edge-based gateways that are communicating to your backend. And obviously these edge gateways are a lot more powerful and can have a lot more security capabilities and services applied to them. So, we had our table that we looked at in the beginning. Now we take a look at that same table and compare to what 5G can do, right? So the large volumes and the different types, we talked about using network slices to divvy up how those devices connect to the network and what resources they can get access to. We can use device adapters and edge-based solutions to manage all of these devices. And of course, you can reduce your risk again by enabling network slicing and then enabling security capabilities at the edge on a per need basis as well. So you put all of this together, right? And what you have is an edge-based, virtualized, automated security control capability that you can deploy, right? With the advancements in machine learning and threat detection that are happening in the industry today, moving those closer to the device and using those to protect the device before they can impact anything on the downstream, any of the services on the downstream becomes very important, right? And enabling that zero trust environment is also critical. But one thing we all have to remember is that at the end of the day, even though 5G brings these new capabilities, it is still a shared security model, right? The network is still not going to be able to protect the entire ecosystem. So we must ensure that we take responsibility for the entire end-to-end ecosystem and ensure that there is end-to-end security before we go out and deploy. And that's my last message for your takeaways for this session, right? So before you start looking at what IoT deployments you are going to make, the first thing you need to really understand is how significantly different IoT is from existing IT systems. That understanding is very critical to ensuring that you're able to identify the security gaps and the risks that IoT brings to your enterprise. Understanding the capabilities that 5G brings to the table is important because the 5G is going to be an essential tool that is going to help you secure your IoT ecosystem. Once you start and get into the architecture stage, right, take a look at your specific IoT deployment, what its security needs are, what network capabilities it requires, and then define what the IoT solutions that can be used for it are, right? You'll have to perform a risk assessment first to understand what risk this deployment brings to your enterprise. And then based on the security solutions you're deploying, you can then define what the acceptable risk level is, right? And that's going to depend really on your cost and your capabilities. And once you deploy, you have to continue to monitor and manage the security of the entire ecosystem. 5G, again, that user domain or application domain allows you to continuously improve your security policy that you're applying to your devices. You can also run testing and audit capabilities at the edge as well. So, a lot of capabilities there. That's the presentation. I do hope that the presentation has been useful for you. Please reach out to me via Slido if you have any additional questions. And my social media tag is is available too. So feel free to tweet at me if you have any questions outside of this session. And again, thank you for joining the session. Britta, I'll hand back over.